Welcome to the Fast Mode podcast series. I'm Tara Neil, and with me today is Omar Al-Anni, the CEO and founder of TelcoBrain Technologies. TelcoBrain drives the future of cognitive networks, empowering telecom, industrial enterprises, and cloud infrastructure providers to move beyond rule-based automation to truly intelligent, self-optimizing systems. TelcoBrain redefines network and cloud evolution and operations through its next-gen approach that integrates agentic AI, digital twin technology, and techno-economic intelligence to eliminate inefficiencies and reduce TCO while enabling sustainable revenue growth and profitability. With over 2 decades in technology, Omar has led major M&A integrations, spearheaded digital transformation for global CSPs and enterprises, and built high-impact AI, network, and cloud-based solutions that drive efficiency, reliability, and new growth opportunities. His expertise spans executive strategy, deep technology, and the economics of next-gen networks. Omar joins us as part of our exclusive editorial segment on generative AI for network management. Welcome, Omar. Great to have you on today's episode.
Glad to be here.
Okay, so let's begin. Starting with network planning, how does TelcoBrain leverage digital twins and techno-economics to drive smarter, more efficient network evolution?
Sure. So the current status quo of digital twins for networks is like looking in the rear view mirror. They capture real-time data to show how the network looks like today and finding hidden issues that exist, maybe providing indicators for future issues, but they fail really in providing full picture or model how the network would evolve in a month, in a year, and 2, 3, 4, 5 years down the road. Because this is a very, complex problem. Most importantly, or beside this, they miss out on critical business realities like total cost of ownership, TCO, CapEx, OpEx, revenue growth, revenue impact, sustainability of the revenue, customer experience, how to link it to the network to a higher degree. Having all these together, these are essential for digital twin, and we don't see it in the current in the current digital twins offered in the market. And if I look at it, this is a complex problem to solve, especially when I look at the evolution part of things. And I understood this before founding TelcoBrain, having worked at the vendor side, customer, even at consulting services sides, building networks for CSPs and enterprises and across different industries. I realized how complex and important that dimension is. To understand the level of complexity here, it's not only about different types of different types of data, or the amount of data, or level of accuracy, data pipelines, or you name it. But it's much more than that. It's about a multidimensional problem bound by time. What do I mean by that? Take it or think of it like a time series. You have today, tomorrow, a week, a month, 2 years, 3 years, 4 years. You go all the way to 5, 7 years down the road. And there's accuracy. That's the third dimension. So it's really complex to model the entire network, taking care of all these different dimensions in a time series. And what are these dimensions? So, architecture, how my architecture looks today, how it will be in a week, in a month, so on and so forth. Similarly, vendor choices, how do they evolve along that? Demand changes, TCO ROI goals, energy, for example, consumptions. What's my ASG? Many other factors you can put in there. It's really hard problem to solve. Our approach was to solve this problem by going head on and solve, the digital twin and the future evolution side of things. Starting point was for us really to turn the deep know-how expertise in the networking domain into algorithms. Combined with AI, we were able to build the future evolution scenarios and modeling capabilities, capturing highly accurate model of the network that can go from today to a year, 2 years, 3 years, 5 years from now. Now, having said that, you might have heard about recent maybe techniques from DeepSeek to improve their LLM beside other things. That's exactly what we have been doing over the last years. Deep expert techniques building these algorithms, turning them into the software, combine them with the digital twin, and that's how powerful our digital twin is. In terms of insights and in terms of capturing accuracy and full dimensions. The last thing that we have actually made, and it was kind of, I would say, industry first, because I haven't heard about such a software or such a platform that offers this in the market today. We brought in the techno-economic aspects in here. So this is where we took all the experiences of how we can financially evolve the network. How can we predict the TCO of the network, the revenue of the network, along with the evolution of the network model in the digital twin. So this means the digital twin can precisely model the entire network evolution along with the key business financial metrics such as TCO, revenue, all these aspects. And by doing that, our digital will empower CSPs and enterprises to make smarter decisions, more sustainable choices, and balance performance and with cost efficiency. Imagine you would be able to answer as complex problem as or questions as, can I optimize existing assets before deploying a new infrastructure? What kind of choices do I have? Hundreds, thousands of choices, probably shortlisted to top 7, 5, 8, answers, but then you need to quantify those answers. All that can be done with one single click. So that our digital twin delivers insights and actions in a second.
Wow, these concepts are really interesting, especially techno-economics, the way it looks at and ties together the strategies and then the financial bits as well as the network, all the elements of the network. So great. Okay, moving on. We have heard about the 6 levels of network automation. Why is TelcoBrain focusing on cognitive networks instead?
Absolutely. So it's great to see you read my latest blog on our website about the 6 levels. So that's great to see. Well, the 6 levels of network automation describes the journey from manual operations, what we call level 1 reactive, to fully automated networks, level 5 or autonomous. And by the way, there are many names like, zero touch, autonomous networks, self-driving, you name it, right? But let's focus on these first 5 levels for now. It's essentially in these 5 levels, essentially where machines takes over operations based on predefined rules or rule-based automation with RPAs. The goal has always been to shift from human-driven decisions to machine-driven automation. But here is the problem. Networks don't operate in a vacuum. They're constantly evolving, facing unexpected failures, traffic anomalies, and security threats. Traditional automation, even at level 5, still bound by static and predefined responses. This is where level 6 comes into the picture, which we call as a cognitive networks. And this is where the real transformation happens. It's not just about eliminating heavy human interventions, it's about creating a new network that understands, learn, and reason in a real time beyond the rule-based automation. Cognitive networks don't just optimize technical parameters, but also they factor in business goals, customer experience, financial trade-offs. They move beyond reacting to problems and start predicting them at a mass scale. Because in some of the level 5 automation or level 4 automation, there is some prediction about certain anomalies, but not at the scale, not at the reasoning level that we're talking about. So that can give adaptation dynamically without waiting for human input. So we are talking about entirely new way of operating networks and cloud infrastructure resources. So the real question isn't about reaching level 6 for us. It's about unlocking fundamentally new future for networks, one where automation isn't just about efficiency, but it's about intelligence, where network can think, learn, evolve, and also makes a true future.
Amazing. Well, taking a closer look at what you just said, how do Gen AI and Agentic AI fit into the automation journey, specifically cognitive networks, and what real impact do they bring?
Oh, I can go all day long on this topic. It's very close to my heart. But
Yeah. Yes.
yes,
Yes.
but I mean, let's break it down a little bit. So, Gen AI and Agentic AI aren't just upgrades to automation. They are enabler of a true cognitive networks, but their roles are distinct. Think of cognitive networks as an advanced intelligence system. Gen AI is the cognitive layer. It processes vast amount of data set, learns from patterns, and generate insights that traditional automation simply cannot at scale. It allows networks to move beyond reactive responses to predicting failures at scale, forecasting demands in a future manner also, so time series, and recommending optimal configurations as an example. So by intelligence, but intelligence alone isn't enough. Agentic AI here is going to play a big role as an action layer. So while Gen AI is the cognitive layer, agentic AI is the actual action layer. So it takes those insights and autonomously execute decisions. Unlike traditional automation, which follows static rules, agentic AI continuously learn, adapt, and make independent decisions based on evolving conditions. So it understands trade-offs across performance, cost, sustainability, and many other parameters you may configure or you may add. All this happens dynamically, right? So this means networks can now optimize themselves autonomously. Take an example of managing spectrum allocation in 5G all the way to rerouting traffic from point to point in response to congestion. In cognitive network context, all detection optimization can take place without human intervention, but always with sort of guidance. While in level five, and maybe even lower than that, with some high level of automation and anomaly detection, all these issues can be detected. But there is a space or there is a need for engineers to constantly feeding in new configurations, new policies into the system. Cognitive networks cut all that because it learns from their own environment. This shift, what moves us beyond automation into an era where networks can no longer are no longer just managed, but actually they manage themselves. So here's the bottom line. Gen AI enables networks to think, while agentic AI enables it to apply actions.
Interesting, interesting. You know, the way you explained, the distinction between Gen AI and agentic AI, because we see a lot of talk about both concepts, and I see now that a lot of operators are starting to talk about agentic AI, but a very good understanding of these both concepts is, I feel, crucial. As we move ahead. So, where do CSPs and enterprises currently stand in adopting automation and cognitive networks?
Yeah, another great question. And I've been in this industry for the past decades, 2.5 decades plus. So lived through many automation, I would say, eras. But the adoption curve for automation and cognitive networks is interesting because it's not binary or a simple switch that someone may wish to press. It's actually a journey, right? So believe it or not, there are a handful of CSPs enterprises as of today. But when I speak about enterprise, I'm speaking about enterprises that manages and operate large-scale networks, right? Likely mission critical networks. So many of those that still works until today under a reactive model, slowly moving to or transitioning towards a proactive one, all right, injecting some AI, what have you. At the same time, a handful of CSPs and enterprises that actually on a good path towards their automation journey, primarily application or usage of or using AIOps, rule-based automation to highest degree for tasks like fault detection, incident responses management, basic optimization, network management as well as an overall. So these efforts have delivered efficiency gains, but as network grows in complexity and demand more adaptability, these traditional approaches are reaching their limits. So this is where actually cognitive networks represent the next stage. But the adoption is still in its early phases. Many organizations are experimenting AI, Gen AI, leveraging technologies like we know about the LLMs are being used by multiple operators nowadays, but mostly on the customer care sell side of things. Few, I would think, implementation or examples on the network management. We've seen that with Verizon and a few others. But full scale implementation is still very rare, I would say. The challenge isn't just technical, but it's cultural. Companies need to trust AI and higher stakes decisions. from AI. So, which requires governance frameworks, transparent AI models, and critically shift in the mindset. So, at the end of the day, real differentiator who would be, I would say, won't be who at what level now, but who adopt AI now and who learns to trust it first. So the companies that lead this transformation won't just implement automation and adoption of AI, they will empower to drive real-time decision making while ensuring, and this is a very important point, while ensuring their human expertise guides that evolution. That's actually what we believe in.
And I guess that's where telco brain comes into the picture. So shifting back, can you tell us more about telco brain's star loop? How does it compare to the AI ops cycle of engagement, automation, and monitoring?
Right, right. So we touched a bit on AI ops. I think it's worth also to unpeel it a little bit. So we started the Star Loop last year, which is essential in our vision of cognitive networks. It stands for scan, think, apply, and refine, transforming network intelligence from a linear automation process into continuous adaptive cycle. So let's start with AIOps. So unlike AIOps, which focuses on detecting and responding to unknown issues or known issues, the Star Loop enable networks to continuously learn, evolve, and optimize over time. If I maybe just quickly try to break these elements even further. So scan, this is the observability place where you observe and collect all the data, and not only technical data, so technology related data regarding network topology, what have you, or traffic. This is also covers all the user experience metrics, economic metrics, indicator, financial indicators. This is where you have the 360-degree view. And then think, this is where the key difference happened specifically between AIOps and cognitive networks. Because AIOps is great at responding to known issues and small degree, I would say, of identifying unknown issues. So as it detects anomalies, patterns, issues, what have you, it presents them for human analysis or presents them to already predefined loops, to rules to process them and to act on them. So, but still operate within predefined boundaries. It doesn't fully understand the network context or understand the network beyond what it has been trained on, if you see what I mean. Cognitive networks, completely different ballgame. So here you are looking going further by tackling unknown unknowns, those hidden inefficiencies, patterns, optimizations that a human wouldn't even know to look, to even know, what to look for. Instead, just surfacing insights, the system deciphers these unknown unknowns, learns from them, and apply intelligence to solve them autonomously. I brought in this maybe these two terminologies or maybe analogies. In the case of the AI ops, it can deal to a higher degree with known issues and maybe unknown issues, while the cognitive can deal even with unknown unknowns, which is a widely used, I think, terminology in Silicon Valley VC circles and AI research, which describes how higher level of intelligence can handle uncertainty. And that's what we're looking here from the thinking and reasoning perspective. So while traditional automation and AI ops operate in a world of known problems, cognitive networks break through the limits of predefined logic, continuously evolving and optimizing performance, cost, and resilience, etc. So that's on the think and reasoning. Then applying, which this is where all the actions takes place. And then refining, this is very important because the AI system or the cognitive layer can learn from its own action with human supervision as well. So that's a very important aspect. I mean, as a wrapper here, or let's say this is another way to look at it. AI ops step forward in the traditional rule-based automation, but still follows detect and respond model. Cognitive networks powered by Star Loop go beyond this by actively learning, reasoning, adapting, and optimizing in real time without waiting for human intervention. Only needs an oversight.
Brilliant. I mean, it's amazing, how fast networks are evolving towards becoming, less and less human dependent, and yet more and more accurate in terms of network actions. So I think that's a huge feat, in recent years. Well, I think to wrap things up, we would like to know a little bit more, which is basically what are the challenges do you see or foresee as networks evolve from automated to cognitive?
That's a very important aspect, I think, and very, very important to realize actually this vision or our vision as well. So, as network moves beyond automation into true cognitive capabilities, I think one of the biggest challenges will be ensuring trust and transparency. So, as we have been discussing, cognitive networks make real-time AI-driven decisions, etc., whether optimizing traffic, balancing workloads, reducing costs. But operators need to understand why these decisions are made. As an example, if an AI recommends significant network reconfiguration or changes, decision makers must be able to trace its logic, validate its impact, and trust its reasoning. And this is where we are addressing this by building explainable AI frameworks that provides higher insights about cognitive actions, ensuring decision makers remain in control. Other aspect I could think of it, also we're seeing repetitively, is the continuous learning at scale. And that comes from maybe few dimensions. So networks are dynamic, AI must adapt without unintended behaviors. High quality data here is crucial. Some degree, I think, while especially in the telco space, there's a lot of data that we can get, but also on the other side, well, we need more data to train or to get better quality models. So this is also an issue that we are seeing in there, but we believe in human oversight over this continuous learning. So while the system learns by itself to a higher degree, but human oversight or the human switch is always there to balance and maintain the robustness and the reliability of the cognitive capability. So security, I would say, another aspect that is very important for networks or for operators to move all the way to become fully cognitive, ensuring a robust safeguard against adversarial attacks, compliance breaches, unintended AI actions, really essential. This is where we have also secured by design AI principles, where network intelligence is basically auditable, resilient, continuously monitored for anomalies. And finally, there's a growing demand for advanced AI talent. I think we see this all over the place, not only in the telco industry or enterprises, healthcare, and many other industries. So building cognitive networks requires deep expertise in both AI and networking, so deep domain knowledge. But there is a global shortage, I mean, in terms of professionals who can really bridge those domains and understand those domains. So our take on it, we're addressing this by designing intuitive AI interfaces and automation layer that lower the barrier to adoption. So meaning allowing engineering experts, professionals, executives to work alongside AI rather than needing to be an AI experts or professionals themselves.
Well, awesome. So I guess, yeah, we learned quite a lot today, and we are basically at the end of our session. So thank you so much, Omar, for joining us and for sharing your insights on the automation journey for CSPs, the impact of generative AI, and the role of TelcoBrain.
Pleasure to be here. Thanks for having me.
And to everyone tuning in, thank you guys for listening. If you want to learn more, visit www.telcobrain.com and follow us for more updates and insights as we continue to uncover the latest in technology and telecommunications. See you in our next session. Bye bye.